Okay, so let's get started. Please, for the online attendees, please let me know if you have problem hearing me or looking at the or seeing the screen I shared for the tutorial. Okay, so here is an overview of before we get started. Today's workshop will break down into two sessions. The first hour, I will just go over the training materials and tutorial, and then for the second hour, you will work on the hands-on exercise on yourself. But you will be able to ask questions whenever you have any problems with the tutorial. Okay, so here's the overview for today's training. The high-performance computing clusters like the one we are going to work on today, Tillicum, use a job scheduler to manage and optimize the resources on the cluster. Imagine that we can have hundreds or even thousands or more users using the system at the same time. So how everyone's job are organized or managed. So the scheduler will coordinate how and when jobs are executed across available CPUs, GPUs, memory, or other resources, ensuring efficient and fair share of the system. And the tool used as the job scheduler on Tillicum is called Slurm. That's the job schedule used across the Hyak cluster, which is the cluster on campus, including Tillicum. It handles job submission, resource allocation, and queuing, enabling thousands of users to share the cluster efficiently. If you are interested in this job scheduler, you can visit the documentation for it. And there's one thing special for the Tillicum cluster is that Tillicum is a GPU-only cluster. It's designed for compute and AI-intensive workloads. So all jobs on Tillicum must request at least one GPU when you submit a job. And here's the contents we're going to cover for today's tutorial. By completing the tutorial, you'll learn how to submit and run both interactive and batch jobs with Slurm and understand the different queues and resource billing on Tillicum, and learn how to monitor job status and resource usage. Write a simple bash script to set up your workflow and launch array jobs for parallel computing. And all the training materials are contained in this repository. So after this training, if you haven't completed the tutorial or if you want to explore more, you can always come back to this repository. This training will also be recorded. So when the recording is ready, a link will also be posted here. After you finish the tutorial material or after finish today's workshop, please take a moment to fill out our feedback form so it can help us to improve our future trainings. And here we have some additional resources, including the documentation for the Tillicum cluster, which has a lot of really helpful information for the Tillicum system, so that you will know the computing environment on this system and a lot of useful tools or softwares on this system. And also, there are two previous Slurm tutorials, but they are on the different cluster on campus named called Hyak clone. So that cluster is has both CPUs and GPUs, so there will be some differences. Okay, so let's head to the first part of the training. Before the training, we need some preparation. The first thing we need to do is to log into Tillicum. So we can connect to Tillicum via the security login, the SSH. And the command, you can copy the command here directly, but please change the UWNet ID to your real UWNet ID. And you will need to type in your password. Your password won't show here. Sometimes people will think that they haven't typed anything, but it's just not print on the screen. And then choose the two-factor authentication and grant the access. So now you have logged into Hyak. Please let me know. I have added you to the training group, so please let me know if you have any trouble logging in. That's the starting point of today's session. Yeah. And after you, the first place you landed on the system is your home directory, which represented by the tilde symbol here. And the prompt actually, after you log in, the prompt will change from your local machine to the remote machine Tillicum, and you landed on the login node. So the prompt you will see here is your UWNet ID at Tillicum-login node, and with the your current directory, working directory. And after you log into Tillicum, the next step is to create your working directory, or tutorial exercises will be done in your own working directory. Usually, we recommend starting your working directory in a file system location where you have a large storage quota. Typically, that should be your project folder. But in this case, you are just demo users, so you don't have a dedicated storage location. So here we will use the Tillicum's free community storage under GPF script. And so the contents in this folder will be erased if not accessed within 60 days. So that's why we call it script. And one thing to notice is that the quota for your home directory is rather small. It's only 10 gigabytes. So usually we only put the configuration files in your home directory. We don't do any work there. Otherwise, it will get full easily. And we got a lot of tickets or emails regarding their quota exceeded in their home directory. So next we navigate to the script folder, use the command CD, stands for change directory, and GPFS, and you can use tab for auto completion on script. There are already a lot of folders here. So LS for list, to list the contents in the folder. There are a lot of directory folders here. They are created by other users. So please make your own directory with the command make directory, followed by this variable $, user in capital. I cannot create the directory because I already created one for myself previously, but you should be able to create one for yourself. So after you create your directory, you can change directory to your own directory under the script folder. And next step is to clone the training repository. So you can copy the command here to clone the whole training repository in your own directory. And now you should have the Tillicum -Slurm folder under your script folder, and then change to it. So if we list the contents here, it will contain all the markdown files for today's training materials, as well as all the scripts we're going to use today. So that's the necessary preparation we need to finish before today's exercise. I may won't go step by step for the following materials, but for this one, I just want to make sure it works for everyone. Yeah, okay. So, okay, let's get started for the real contents of today. How can we schedule jobs on Tillicum? When you first log into Tillicum, actually we landed on the login node. But please remember, login nodes are for light activities like navigating the file system, transferring data between your local machine and the remote machine, or between two remote machines, and setting up your software environment, such as setting up the parameters, or no, the variables, the environment variables, or if you want to load any environment, you can do that in your on the login node, or preparing the job scripts. Don't run any compute heavy work on login node. Actually, we have a program called UWIT that will forbid you for doing so. Yeah. So you will receive an warning email, I think, if you do any heavy jobs on the login node. So we need to use Slurm, which is the workload manager used on Tillicum. It will locate compute resources on the cluster and determines when the job starts and decides where they run. Slurm ensures efficient sharing of the cluster among all users. And there are mainly two types of jobs to run your work on Tillicum, the interactive job and the batch job. To launch interactive job, we use the command alloc. It's better for the exploratory or hands-on work, such as the debugging or testing. And with alloc, you will directly connect to a compute node. And another tab, the batch job, we can launch it with the batch command. And that's for long or unsupervised jobs. So Slurm will schedule your job and run it automatically when the resources are available. And an important concept on Tillicum is the QoS, or quality of service. Each Tillicum job is submitted under a QoS, which defines the limits of the resources, such as the longest runtime, the GPU count, and how many jobs you can run simultaneously. All Tillicum compute nodes have 8 NVIDIA H200 GPUs and are provisioned with around 200 gigabytes system RAM per GPU, associated with 8 CPUs per GPU. So here are the QoS we have right now. For the default queue is the normal queue, and you can have 24 hours. The jobs in normal queue can run at most for 24 hours and requires 16 GPUs per job at most. And 3 jobs can run concurrently. So that's for the standard production work. And another QoS is called debug queue. And that's really short, only 1 hour for one GPU, and only one job per person running simultaneously. That's just for quick testing and setup. So this queue will have a higher priority. If you submit to this QoS, then your job, there's a large chance that your job will start faster than the normal queue. And interactive queue is something in between. That's only 8 hours on 2 GPUs maximum and 2 jobs simultaneously at most. That's for real-time work or debugging or open on demand, the web portal we have for graphic interface. And there are 2 special queues, the long and wide queues, for extended runs or distributed work. But those 2 queues are only available by request. So it needs the approval from the facilitators in research computing in a case by case. And for all of those queues, you must request at least 1 GPU. CPU-only jobs are not allowed on Tillicum. If you want to run any CPU-only jobs, you can consider the other cluster on campus, the Hyak clone. And for all students, you can access clone through the technology fee funded queue. Yeah. So the Tillicum is a usage-based billing system. So instead of buying the hardwares, you pay as you use the system. And the billing formula is shown here. It's calculated by the GPU hours multiplied by the rate. And GPU hours is the elapsed time multiplied by the number of GPUs you use, the job request. And the rate is 0.9, 90% per GPU hour. That's quite low actually. And billing is processed monthly through our ITBO system. And it closes on the end of day on 25th of each month. There will be a special queue to be implemented called urgent queue for anyone that has a solid deadline that also needs approval and is not implemented yet. But for that queue, it will has a cost factor or the multiplier to the raw GPU hours when calculating charges. Okay, so when you submit the job, Slurm actually will show you an estimated cost. That something look like this. So if you submit a job with an interactive job with slog, after the resource information showing up, then it will show you an estimation of the cost. This estimated cost is based on the full request runtime. Although jobs usually ends before the maximum time you request, this estimation will help you understand the maximum charge for each job you request. And for both the slog and bash command, there are some common arguments they accept, or we recommend you specifying those arguments in case that you request more resources than you want. So on that, those arguments are the account specified by -A or -account. It tells the Slurm which project or lab account to charge, and the default will be your available account. So for example, today, if you don't specify account, then it will charge charge the training account you are in, yeah, by default. And then the second one, the one of the most important flag is the QoS, specified by -Q or -QoS. It's the quality of service, and the default queue is normal. And also how many nodes you want to request. I think usually it should be one. Multi-node or multi-GPU jobs are possible, but it needs to be supported by your code. A lot of people request multiple nodes or multiple GPUs, but they don't know that their code is not optimized to utilize or distributed across different nodes and queues and GPUs. So that's need to be verified by yourself. Otherwise, you may find even if you request multiple nodes or multiple GPUs, you are actually using only one GPU and all of the other resources are idle. But the charge or the billing are based on the resources you request. So please make sure that you really take advantage of the resources you request. And then the GPUs, the minimum GPU request is 1. And then the memory, you want the per node. And the maximum memory you could request is per node is per GPU is 200 gigabytes. And the time period or the maximum time you'd like to request, please note the format shown here. And for more options, you can see in the slog or sbatch menu. Okay, so let's get started with the interactive jobs. Interactive jobs give us a live share on a compute node, and it's great for testing or exploring. And we can start an interactive session using one GPU for 1 hour in interactive queue. So please copy the command here. And you should be able to request the resources from the interactive queue using the training account. And the first job will wait in the queue, and when the job starts, the message is similar to what's showing here. And below the estimated cost, the most important information you should keep track of is your job ID. So Slurm will assign a job ID, a unique job ID to each job running and to each job submitted. And keep track of your job ID, so it would help yourself or us to troubleshooting if your job fails. And then once the resources are allocated, the prompt here, you will see it changes from the login node to something yours should be similar. G followed by a 3-digit number that stands for different nodes. And actually that tells you are on a compute node. And this can also be confirmed by the command host name. It will tell you which node you are on. Here it's G004. And for me, and then you can check your GPU availability by the NVIDIA utility NVIDIA SMI. And here you should see the GPU details. For example, the name of the GPU NVIDIA H200 and also the driver versions and the CUDA versions. So those information confirm that you are on the GPU node and the GPU is visible to the system. And to end the session and release the resource, please use exit. So in that case, your job is terminated and the cost will not increases. Yeah. And the second type of the job is the batch job, which can run unattended. So resource requirements and commands are defined in a script called the Slurm job script. And here we provide an example job script. Job.slurm. To view this Slurm script, we can use the command cat followed by the name of the script, job.slurm. And it print the contents of in the script on the screen. So you will see that all the splash flags, all the information, the job details we want to provide to Slurm is defined in this block, and then followed by the command we want to run. So we can submit the job using the splash command, splash job.slurm. And in this case, you will see the information for your splash job and also the job ID assigned to your job. And your job will queue in the for execution. And when resources become available, the job will start automatically. And the command to check your queue is sq-u and your UWIT ID. So you will see that I have a job running. Okay. And to cancel a pending or running job, you can use the command scancel. And followed by the job ID. Use the up arrow to get the history of your commands. So in that case, you can see that the status of the job changed from R stands for running to CG stands for completing. Yeah, so more details for how to monitor jobs with SQ are given here, given in this following session. Okay, let's submit the job again to monitor it. Splash job Slurm. we have already checked our running and pending jobs with the SQ-U and followed by your UWIT ID. And you can also watch your queue refresh every 10 seconds with the watch command. So in that case, the contents, the status of your job will be refreshed every 10 minutes. And if you want to exit the watch, you can use the Control C for the keyboard interrupt. And that's a general or very common way to terminate any running processes with the Control C. And SQ actually lists all your running or queue jobs. Here we can see there are several columns printed out with SQ. The first column is the job ID, that's the unique number assigned to your job. And then the partition here, all the nodes on the Tillicum system is GPU H200. And then the name of your job, it's my job defined here in the Slurm script. And then the user submit the job and the status of the job. And the status code can be PD for pending. That means the job is waiting in the queue. And then R for running jobs, and CG for completing jobs, CD for completed jobs. And then the next column is the time. That's the time that the runtime duration for the particular job. And then the number of load nodes, and then the node list. Load list is the nodes assigned to the job, or if it's pending, then that will show the reason for the pending job, such as it's the priority or the limitation of the resources. And for more details, or if you want to customize the output format of SQ, please refer to the SQ menu. For all those Slurm commands, you can also view the menu as a command line in command line interface using the command man. So for example, man SQ, it will show you the menu from Slurm. And you can quit with the queue. If you want to check the cluster-wide node availability, you can use sinfo-r. So now it will show you the status for all the nodes on the cluster. So you will see that there are 17 idle nodes right now on the cluster. So that will help you to have an overall feeling of how busy the cluster is right now. Okay, so now we know how to submit interactive and batch job on Tillicum. Then the next thing we need to know is how to monitor the resource usage, including the job status and the billing. Efficient use of Tillicum's GPUs and the compute resources starts with understanding how to monitor our jobs and usage. Slurm itself provides some built-in tools for checking job status, performance, and resource efficiency. Tillicum itself also provides the Hyak usage utility for monetary costs and budgets. And we can check job accounting information with the command saccount. Saccount displays accounting data for all jobs and job steps in the Slurm database. It's very useful for reviewing job history, including elapsed time, the resource request, and the job states. And to view all running jobs on the cluster, we can use this command. You can copy it. So here are all the running jobs on the cluster. And let's break down the command. So here -s is to specify the states we are interested in. Here is the running job. And then -A show jobs for all users. And if you want to see jobs for a particular user, you can use the flag -U followed by the UWIT ID. And then -O is is to customize the output format. In this case, we want only user job ID, elapsed time, account, the QoS node, and the resources requested. So that's the columns you can see here. Yeah, that's pretty here. And you can adjust the percentage sign, the number followed by the percentage sign to adjust the column width if you want to fit long text values. And if you want to view all pending jobs, and it's a similar command, except changing the status from running to pending. Okay, so because we already see that there are a lot of idle nodes, so actually there are no pending jobs right now. And then if you want to check a script for your own job, then you can use as account -J followed by the job ID and then -B. It will also print the Slurm script you submit to Slurm. So this can also be used to print script from other users, but only in the case that you have access to their working directory. Usually, you won't have the permission. Yeah. But that's super useful for administrators to help troubleshoot users' work. Yeah, so that's why you need always keep track of your job ID and provide that information when you want to troubleshoot a job. And another command can be used to check the job details is scontrol. It's used to view or modify Slurm configuration, including job step, node partition, time reservation, and overall system configuration. Although most of the commands for scontrol can only be executed by root user or administrators, users can still use it to inspect their own jobs. So for example, if you want to check the details of our own job, we can copy the command here and also the job ID. Okay, I think that's because the job is already. Oh, sorry. This job is already ended. So scontrol can only show active job, which means the job are running right now. So for completed job, the scontrol cannot show any information. So in that case, please change it to a valid job ID, which is the running job. And then in that case, it will show a lot of information here. So what's important here is that you can check the start time of your job and the end time of your job. And also the information for the command that's running, the job script, the working directory, and the standard input and the standard output and error. So that's some useful information for you to debug your work. And another useful command is SF. So SEFF is the command to report resource efficiency for completed jobs. It will help us identify jobs that use significantly less memory or GPU than requested. So that help us optimize our workflow in the future. For example, here we can run the SF command for our job, and then it will show you the CPU utilize, the CPU efficiency, the work log time, and the memory use, the memory efficiency. So that's the information it can provide with us. So usually we want to improve the efficiency of the job here. So next time you can adjust the resources being requested. Yeah. And Hyak usage is the tool provided by Tillicum to track the usage and costs. It will summarize the resource usage and associated costs across users' accounts and QoS levels. It will query job accounting data and present results in a user-friendly, easy-to-read table format. Although we have this tool right now, but users are responsible for monitoring their own usage. By default, if we run Hyak usage without any argument, it will print the usage report for the current billing cycle for the current user grouped by account and QoS. So here is the usage report for me. I have access to 2 accounts. So for each account, the usage data will break down per user and per QoS. So it will only print the results for all accounts you have access to. And it will show the total, it will also show the total GPU hours and costs for the whole group. And if the budget is set for an account, it will also integrate the account level budget usage towards the limit you set. For you, you should only have one session for the train Slurm 2025 account, but this database is updated hourly, so it is not real-time data, and real-time usage report is will be released in a future version. And if you want to explore more about this program, you can use Hyak usage -h to print the help message. So it can have a rich combination of the user account QoS and also a specific time period if you are interested in. So for example, if you want to see the usage for all users in your group, you can use the command Hyak usage -u all. Oh, sorry. So that will print all the user which have who have used the resources in the table. And I think for you, because it haven't been allocated, so you should only see me. Yeah. And also you can specify a different time window. Okay, so now we know how to submit the jobs and monitor our jobs and usage. Then I like to switch the topic a little bit to look into the bash scripts in depth for our jobs. Bash scripts will allow us to automate, reproduce, and document how our workflows run on Tillicum. And instead of typing every command interactively, you can write your job instructions once and submit them as a bash script. Slurm will then execute the script for you on a compute node when resources become available. So in this session, you will learn how to use bash scripts to organize your workflows, set variables, load computing environments, and run commands automatically with Slurm. A bash script is actually a simple text file containing a sequence of commands that you could otherwise type directly into your terminal. When you submit a script with bash, Slurm executes it line by line on the compute node. So here we use a simple script as a command proxy, and the example script is called loop underscore script dot sh. So you can take a look at it by cat command. And here it defines 2 variables that accept 2 arguments for this script, the starting number and the end number. And then the if condition checks whether the 2 arguments are both given. If not, it will provide usage instructions. And then the for loop, it iterates from the start to the end value. And the echo command here, it prints a message once the job is done. And to run it interactively, we can use the // with the desired starting and ending points. So for example, here we can use loop script .sh followed by the start and end values. And it will print the message when the job is done. And you can also measure the runtime with the time command. So the output should be something similar to which one I have. It will show you the time used to run the script. And then next we'll run the same command as a batch job, so it can run unattended through Slurm. We can write a simple Slurm job script. It usually includes 3 sessions. The first line is the shebang line that tells the system to interpret your job with bash. So it's a bash script. And then the 3 sessions, the first session is the job information, which is the job directives. So all the pound splash flags are in this session. And then the environment setup, you can load modules to use prebuilt softwares and set up or load virtual environment and define variables. And then in the end is the actual command or workflow steps you'd like to run. So let's look at a minimal working example loop job./. So you can use a cat command to take a look at it. So I have also placed the content here. So you will have the splash commands and then the command we want to run. And so for the here we don't have an environment setup, but it can be the module load or activate environment or export define the parameters or variables. And then this is the workflow, the actual command or the actual computation or analysis we like to run. And the echo command here is just print logs and timestamps to track the job progress. And all the batch directives must appear before the first executable command in the script. So it needs to be the first session, just exactly followed by the batch line. And then we can submit the job with batch. Oh, sorry. I think yeah, it's not this. It's other there's typo here. The script should be loop job. Yeah, and then you can check. We have redirect the output into a folder called logs. Change to that folder, and you can cat the output. So actually, it prints or it saves the output into the slurm dash your job net ID .out file. And we can also set up and use variables for our Slurm script. It makes your script more flexible, readable, and reusable. And we show an example here in the loop var.slurm. You can cat loop var.slurm, and you will see that we define the variables, working directory, work directory, and the name of the script. So in that case, you can use the commands with the variables defined. So when later you need to change the working directory or the script, you don't need to change every appearance for those two. You only need to change the definition of the variable. And besides the setting up the variable, you can also load or unload modules in the script, such as load purge, module purge, to unload all modules from the current session, and module load necessary modules. And if you want, you can also copy those sessions into your Slurm script to see what will be printed out. And you can also set up the custom environment variables. So for example, here we set up the variable OMP num threads, the number of threads. That's for the OpenMP parallelization parameter. And also, if you check the file, you can see that the output file is specified with the -- output flag. By default, both standard output and error are redirected to the file named slurm job ID and dot out. And here the %J will be replaced by the job ID assigned to the job. And for job arrays, we can also include the task or the array index for each task. And in a lot of cases, we don't want to mix the standard output and standard error. So in that case, you can explicitly specify the output and error flags to save standard output and error files separately. So here is the example. This approach helps organize the job logs by job ID under a designated directory such as logs. To control whether Slurm appends or overrides the existing file, you can use the open mode flag to change between the append or override the truncate. Within your job script, you can also redirect the output for individual commands. So for example, this command to a file called, here we define as output.txt using the standard shell redirection, the larger than sign. That's for overwriting. If you want to append, use the double larger than signs. This will write all standard output from the particular command to the output file you define. Okay, so in the last session, we want to introduce the parallel computing with array jobs. Running multiple independent tasks in parallel is one of the core strengths of HPC systems like Tillicum. And Slurm actually provides built-in mechanism for parallel execution, from job arrays for parameter sweeps to distributed jobs using MPI, the message passing interface. In this session, we will go through a complete example using Slurm job arrays. It will harness the power of parallel computing, and it allows you to efficiently launch and manage many similar small jobs, such as processing multiple input files, training several models, or running parameter scans in a single submission. And the script we provide here can be used as a template, and it can be adapted for your own workflow. Okay, so let's run an array job with loop array.slurm in your working directory. You can open the example script using the command nano. And the script will be colored in this text editor. And you will see basically the commands are the same, but we have to more flags the array and the array flag, and we change the output to include the the X for job ID, X for job name, capital A for job ID, and small a for the task index, the array index. So here we also define 3 variables, the count, start, end. And then we provide the command, the real command to run. And if we break down the script here, we create 10 tasks from indexed from 0 to 9 here, and then the count, start, and end are defined so that the 2 arguments accepted by our script will be 2 variables in this case instead of 2 fixed numbers. And the start, you can see that in the definition of the start, there is a variable called Slurm array task ID. That's the Slurm environment variable for each task, so that it will be different for each of the array job. And in that case, for each task in the array job, they will actually run between different range without overlapping. And here we provide a table of the start and end point for each of the array job, for each task in the array job. So yeah, so for the first job, the Slurm array task ID equals to 0 as we defined, and count equals to 5 million. So starts equals to 0, and for the first job will equals to 5 million minus 1. And for the second job, because the Slurm array task ID equals to 1, so based on the formula here, the start and end will change. And that's the range that the script will run for the second task, so and so on. So each job in the job array will execute the script on a different non-overlapping range of numbers. And this Slurm variable, environment variable, Slurm array task ID can also be used to select different input files or parameters and to perform parameter sweeps. Please always confirm your array indices, because here we specify it as from 0 to 9. You can also use 1 to 10. So please make sure it match your input list size. And then we can submit our array job. To exit the text editor, you can enter Control C, tap Control X. Yeah. And then we can submit it with bash loop array Slurm, and then watch the progress. You will see that we have 10 jobs in the queue, and because the queue is quite empty, so all of them are running concurrently right now. And once complete, you will have 10 jobs. Yeah. And you can use Control C to exit the watch process, and then change to the log folder, and you will see that we have 10 output files in the logs directory for our array job, with the job name followed by the job ID and the array index for each task. And each file contains the output for one array task. For example, you can take a look at one of the output here. Oh, sorry, it should be cat. Okay, so that's the output for the one of the array task. And the number of concurrent job can be controlled by the array flag. So here, if you use a percentage file followed by the the range of the array. So for example, here we use percentage symbol and then 5. So it will cap the concurrent job to only 5 jobs running simultaneously. So in summary, this demonstration show you how to submit and manage array jobs in Slurm, and use bash variables to define dynamic arguments for commands, and use Slurm environment variables, Slurm array task ID to identify and configure each task. And later, for your own workflow, you can utilize these techniques to automate large-scale training, parameter sweeps, and dataset processing for each computing projects. And so actually, we provide a simple example in the hands-on session, and you can explore it by your own. So I just want to briefly go over the break down the hands-on exercise to run jobs on Tillicum. So for the preparation, I believe you have already done so in our the first session, and then practice starting an interactive job and load the content module to practice load computing environment, and then run a simple Python script. And after that, you will practice submit a bash job. And for that one, we provide a simple PyTorch demo script, and then monitor your jobs and track your usage, and then run an array job with the PyTorch script. And in the end, check efficiency and your usage, and also clean up your temporary files. So that's the basic workflow for the hands-on session. Feel free to let me know if you have any questions. We can take a break, and then you can start working on the hands-on exercise.